good, doesn't it? Yeah, I would go to that session. That guy sounds like he knows what he's talking about. So my name's Elton. I work for Docker, but before I joined Docker, I was a .NET consultant for 12 years, and I worked for a chunk of that time in the integration space. So I was working with BizTalk. I'm not going to talk about BizTalk anymore, but the interesting thing about BizTalk is it kind of forces you to be a bit devy and a bit opsy. So I was bridging both those sides like 10 years ago. So I know more of the ops side than most devs, and more of the dev side than most ops, without wishing to brag. So this session is all about transformation for your existing applications, your legacy apps, the ones that actually power your business and make you money. Because it's a Windows conference, I'm going to talk exclusively about Windows containers, .NET Framework applications in Windows containers. There's no Linux, there's no Kubernetes, there's other stuff for other sessions for that. So 3 things we're going to cover. So firstly, running these legacy .NET apps in containers. What does that look like? How do you make that happen? What are the constraints about putting these things in containers? The bulk of the session is about making your old monolithic applications behave as though they are new cloud native applications. I'll talk about what cloud native means in a second, but so you can treat all your application landscape in the same way. Your brand new stuff that the teams are just pushing out that are microservices, they can run on exactly the same cluster as your 15-year-old .NET Windows applications, all in containers. And then I'll cover that very briefly at the end, how you can run you can have a cluster of servers all running Docker, a bunch of Linux machines, a bunch of Windows machines, all together as a single cluster, and run every type of workload on there, and manage, build, deploy, and operate everything in the same way. Sounds pretty good, doesn't it? Okay, so firstly, this cloud native label that people have been using for a while, I never really liked it. It's useful to have a label, but cloud natives doesn't really necessarily mean anything greatly. But the Cloud Native Computing Foundation have this really good definition of what cloud native means. And there are 3 points to it. Firstly, container managed. So if you want these things that can start up really quickly and scale almost instantly and stretch across a whole bunch of different machines, they have to be in containers, because that's the thing that gives you the ability to start your application in a small manageable unit in a second. And if it goes down, start something else up somewhere else. The second part is the dynamically managed, this idea that I don't tell my server to run this application in a container. I've got my cluster, and I say, here are the applications I want you to run, off you go. And the cluster will dynamically look after all that stuff for me. As part of that definition of my application, I've said, I've got all these components. I need to run 10 containers for my web app to get scale and resilience. I need to have 2 containers for this and 5 containers for that. And the cluster will maintain the service level. So if there's a problem with one container, it just gets thrown away and another one starts up somewhere else. If a server goes down and you lose 100 containers, that's fine. 100 new containers will split up around the rest of the cluster. The third part of cloud native is about it being microservices oriented. So your single logical application, your single product, is actually composed of lots of different feature services that run in different containers. That's not what I'm going to cover today, because your legacy applications are not going to be microservice architectures. And when I say legacy, I mean an app that was started last year is probably not a microservices app, because it's such a recent development and people are not quite on board with it yet. So I'm going to cover the first 2 parts, making your legacy apps fit in with that part of the definition. Okay, so the reason why this is important is because when you're running stuff in containers, and it doesn't matter whether you're using Docker Swarm or Kubernetes or any other type of orchestrator, as far as the orchestrator is concerned, these things are all the same. It doesn't matter whether it's a Linux app running Java in a Linux container, or a Windows app in a Windows container, or a database, or a batch process. It doesn't matter. They all look the same. When you start these things up, effectively when you run your container, what your cluster does is it kind of creates a space for your application to run. And if your application is kind of container aware, it can fill out that space. So if I've got a brand new Node.js application, I run it in a container. The way that Node.js expects to run is as a command line application that sits in the foreground. It spits out logs on the console. Various other parts of how that works fit in really nicely with being run in a container. So it's a first-class citizen when you run it in a container. The orchestrator can understand what the app's doing, and it's really simple for it to fit in nicely with that dynamically managed space. Your old applications, you can run them in containers, but they don't fit like that. So they don't expand to the whole space. So they don't integrate all that nicely with your cluster. So take a .NET application. If it's an ASP.NET Windows app, I can run that in a container. That's fine. But it's going to be running in IIS in the container. It's going to be running in the background. Now, Docker is going to be looking for a foreground process to monitor. It's going to be looking for logs from the console. There's none of that because it's in the background. So what I'm going to cover today is the patterns for making your old apps kind of fill out so they behave like a new application, and your cluster can manage them dynamically. You get all the benefits you've got with your new applications, but for your existing landscape. 5 patterns I'm going to cover around each of these integration points with the cluster. So firstly, logs. Logs out from your application. It's boring, but it's essential. And when you can get your logs out of your application into Docker, Docker has a logging plugin mechanism, so it can scrape them all up, put them in Splunk, put them in Elasticsearch, whatever you want to do. So it just takes care of all that for you. We've got to get them out of your app, out from the container. Second one is configuration. So one of the core things about running stuff in containers is when you package up your application into a Docker image, that's the same image you run in every environment. There's no difference between what you're running in production and what the devs are running locally on their laptop. And that's important because it's the exact same set of binaries that you're moving through all the environments. There's no gaps, there's no differences where a dependency is missing, so something's going to fail, because it's all part of the application image. But of course, things are different in each environment, so I need to be able to get configuration into my app from the environment that it's running in, from the cluster. The third thing is dependencies. So especially if there's an application where it's a distributed app with multiple things running in containers, I need my app to be able to ask the cluster if the dependencies are up and running, so that it can if not everything is available for it yet, it can take action to deal with the fact that some dependencies are missing. Fourth one is health. So that's the opposite side, telling the cluster whether my application is working correctly. Now, if my application isn't working correctly, that's fine. The cluster will kill the container, start up a new one somewhere else. But the application has to be able to tell the cluster that it's not working effectively. And the last one is metrics. So if I want to be able to run my legacy applications in containers so I can move them to the cloud or do whatever I want to do with them, I need to be able to get some metrics out so I can see how they're performing. It's no good knowing that one server in my cluster is maxing out CPU, because there's 100 containers running on that server. I need to know which container is maxing CPU. So getting the metrics out. So when we do that, then we can fill in all the gaps. So we can make our old .NET applications behave in exactly the same way as new ones. Java applications, likewise with Linux. The patterns I'm going to show you are kind of technology independent. I'll be showing you the .NET implementation, but that's just because that's this type of conference. You can do it with any type of technology. Okay, and there are 3 things that are important about this. So firstly, there's no code changes here. The application I'm going to be using for my demos is in a zip file. So it's a zip file from a web deploy that could be a 10-year-old application. I don't have the code. I don't need the code to be able to apply these patterns. The second one is I don't want to take a dependency on a particular container platform. So the way I'm going to show you these patterns works on Swarm or Kubernetes or kind of anything else. There are different ways of doing things, particularly in Kubernetes. Kubernetes has some of the features of Kubernetes let you do this in a different way. But if you do that, then your app only runs on Kubernetes. And it's nice to be able to bake the logic you need into your container so you can run it on any platform. And the last one is don't break the dev workflow. So dev should be able to do Docker container run, bang, and there's your application, without having to know that I need to apply this configuration and set up all these things in advance. So I should just be able to run the container. So those are 3 things to bear in mind. Okay, first one, logging. So all your applications are probably doing logging already, hopefully. Whether the logs are useful or not, that's a different thing. But most enterprise frameworks will have some way of doing logging. And what you need to do is get them out of wherever they're currently being written so that they can be read from the container. So firstly, you need to be able to know where that logging is. Whether it's an event log or whether it's a log file that's being written inside the container, I need to know exactly where it is. And the second thing I'm going to do is I'm going to package a utility inside my container image. So my container image will have my application, but it will also have this utility which is going to read from the log, the current log, the log location, and spit it back out as console lines. And that's what's going to run in the foreground. So my utility is going to run there. It's going to sit and look at the log file or look at the event log and just relay the logs back out. That's all it's going to do. So I don't need to change my application. Don't need to change my logging framework or anything like that. I'm just going to package up this utility that's going to do that for me. OK, so demo. So what we've got here, this is my cluster. So I am running, this is Docker Enterprise, but you can use the command line. It runs on Swarm, so it's the same whether you run it on Enterprise or not. The demos I'm using are all Windows, so you have to use Swarm at the moment. Kubernetes support for Windows was going to be coming this year, but it's recently been pushed to the next release, which is probably going to be March. So if you want to do this now, then everything's going to be done on Swarm. So I have a cluster which has 6 nodes and there's a mixture of Linux and Windows. So I've got a couple of Windows servers in there, a couple of Linux servers. I've got a bunch of containers that are already running. This is actually my production cluster that runs my blog, so I need to remember not to delete all the stuff that's running at the end of the session. Okay, so I've already got an application running up here. Here's my demo application, which is, oh, let's not resend that. Let's just do this. This is not an inspiring application. The source code for this is on GitHub, and if you want to run it yourself, you can, but it's not gonna shatter your business productivity. It's an ASP.NET 3.5 application. So it's a .NET 3.5 app. This could be a 10-year-old app. Actually, I wrote this demo app using Visual Studio 2008, so I've used the actual tools of the time. And all it does is shows this page that does a couple of features. There's some configuration in here, so things like I'm using Log4Net, which is my logging platform, and I've got some configuration in there to say the target for my log entries is this file in the file system. That's inside the container. So the first thing I can do is I've got a button here that says Write Logs, and when I click that, it's going to say I wrote some log entries, and they're going to be inside that file now. Now this is inside a container, so I can go and look at this container and check out the logs. So if I go and look at my Swarm services, I've got my .NET website. There's a single container running it, which has been up since yesterday. And if I go and look at the logs, there aren't any. And we can sit here all day and there won't be any, because the logs are buried in a log file somewhere. They're not coming back out of the container into the world of Docker. They just sat there. Docker knows nothing about that log file or the fact that things are happening to it. So if I want to make this happen, I need to apply my first pattern of making the logs available to Docker. So the original Docker file for my app that I'm currently running is this. So people seen Docker files before? People familiar with Docker? There's a few nods. Excellent. If you're not familiar with the Docker file, it's just a script for packaging up your application. Okay? So the first line is I start from Microsoft ASP.NET 3.5, da, 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 da. So that's another Docker image. It's a public Docker image. Microsoft own that. They apply patches. They release a new version every month. Da, 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 da. It's got ASP.NET installed and .NET 3.5. So Microsoft own that. This here gives me everything I need to run my application. It's got all the prerequisites I need for my app. And then I'm copying in the zip file. So this could be from some previous build server, or just a zip file that's on a shared drive somewhere. I copy that in, and then I run some PowerShell to deploy my application inside the container image. I'm expanding the archive, so I'm just unzipping it, and then I delete the zip file because I don't need that zip file in my final container. And the last thing I do, because this is going to run an ASP.NET website, I remove the default website, which I know is there because it's part of the image I'm using. I don't need that, so I'm going to configure a new website, give it a name, specify the port, and tell it where the path is, which is where I've extracted my zip file. So that's what's currently running. So it's pretty easy. I can take my 10-year-old app, and with 10 lines of Docker file, 2 of which are white space, I can then move that off Windows Server 2003 and into the cloud. But I haven't got any logging. So my version 1, I've got a couple of extra things in here. So firstly, the new stuff's just at the end. So I'm creating a volume. Now, a volume is just an abstraction about storage. So the Docker can write things to c:/logs, and it gets stored separately from the container. And then I'm copying this startup script, which is just a PowerShell script. And then I'm specifying that when Docker starts a container from this image, it should run my startup script. OK, so I'm not doing anything particularly clever at this point. In my startup script, I am starting the IIS service, so I'm starting the web server. I make an internal request to my web application, and that's going to kick off the first log. So when I make that request, the application gets fired up, the log entry gets written to the file inside the container, and then the last thing I'm doing is I'm doing get content to my log application, which is just going to read that log file, and I've got a tail there. So that means this final line here is going to just stop and sit and watch that file. And every time an entry gets written to the file, it'll get written back out. So that's going to come out of the container now. So this is my utility. It's not a complicated utility. I'm just using PowerShell for this. OK, so this is my version 1. So I've already built this stuff, so I'm going to deploy an update to my application. So currently, I am running this. And this is how my application is defined to run in my cluster. So my cluster is currently saying I'm running version 0 of my application image. It's got a network that it connects to, like a virtual Docker network. I'm publishing the port, so when traffic comes into 8090 in my cluster, it goes into 80 inside the container. So I can run lots of different things. And I'm telling it that this is a Windows container. Because I've got a hybrid cluster, that's a bit of a shortcut that just tells Docker, just run this on Windows. Don't try and work out what it is and do it yourself, just run it on Windows. So my version 1 deployment is exactly the same, except that I'm using my updated version of my application image that's got my logging utility in it. So I'm going to deploy this change, which is just going to do a command here. So if you're familiar with it, the definition for my application manifest is called Docker Compose. I can use Docker Compose to run everything locally on my laptop, but I can use the same definition to deploy stuff to my cluster in production. So that's done. So now if I go back here, let's go back home. This was my previous container. This is the container ID, which is actually the host name inside the server. That's the previous one. If I refresh this, I should have, let's do this. I should see a new server ID. So this is a completely new container. It's running the same version of the app because it's the same zip file. Haven't changed anything about the application. I haven't changed any of the configuration. But now when I click write logs, I'm going to get the same output back out. It wrote 5 log entries. And when I browse to the container in here, my cluster is running somewhere in the middle of America. So you know, that's why it's taking a little while to get this stuff. Here's my container. You can see here's the previous container instance, E98, that was running for 19 hours but is now exited because I've replaced it with a new version. Here's my new one that's been running for a minute. So if I click on the new one and look at the logs, there are my log entries. So my application hasn't changed, the configuration hasn't changed. All I'm doing is packaging an extra little bit inside my Docker file, inside my script, to show me the log entries and bring them back out into the world of Docker, which now means I can run them and put them in Splunk or whatever I want to do. My network's a little bit flaky here. OK, so that's the first one, logs. It's boring, but you have to do that, because hopefully your application is currently writing a bunch of logs, and you want to be able to see them in the new world when you move this stuff around. OK, the second one is configuration. So like I said, the Docker image, the output of building that Docker file, is this, logically, it's one very big file that contains your entire application. So it's got all the prereqs that your application needs. It's got all the, any reference assemblies or anything that you need, any configuration you need to set up. You can do registry entries inside your Docker file, anything you need to do. And that is a package that's got your application in it. And when I run that as a developer, or when we run it on a build server and run a bunch of automated tests, I'll have a version. So I'll have version 1, I'll have version 2 of my image. And when I upgrade to my UAT environment and get the users to test it, it's the same image. When I go to production, it's the same image. I need to have configuration injected into my application so that it can run differently in different places, but it's the same set of binaries. It's just the configuration I want to tweak. So for this pattern, there's a couple of things I need. Again, I'm not going to change code. I need to know where my configuration files live. So this is a .NET app, so I've got a bunch of XML files inside my application image. I've packaged the default configuration. So this is important about not breaking the developer workflow. I should be able to run it as a container, and I should get some set of configuration that's already baked in, probably for a development environment. So I can run it on its own, and it's going to work. So that's already baked in. But I know where all those files are, and I'm going to set up my Docker file so that I can inject configuration from the platform if I want to. So when I'm running in production, I'm going to take configuration that's stored inside the cluster and push it into my application through the container. But when I'm running locally, I won't do that because I'll use the default configuration. OK, and this is also fairly straightforward, hopefully. So what I'm going to do here, so version 2 of my Docker file. And again, this is just extending what's currently in there. So I'm still doing my zip file. I haven't changed what I'm actually deploying. I've got some environment variables here. So environment variables are one way of doing configuration. So when I start a container, I can pass in environment variables, and they get surfaced inside the container as a system environment variable. And your app can read from that. What I'm doing here is I'm using environment variables to capture the paths to the configuration files that I care about. So I'm expecting I'm going to tell it where the log4net configuration file is, where the app settings are, where the connection strings are. So I can run it without any of this, and it'll just work using the default configuration. But if I pass in these values, then the application, when it starts up, it's going to look somewhere else for those config settings. There's a couple of things I've got in here, and I've updated my startup script. So my startup script now doesn't just do the logs. What it does when it starts is it checks to see if these things are specified. So if I've been given a different path for my log4net file, I'm going to run this little PowerShell script to redirect it. So instead of it coming from my application log4net.config file, it'll come from whatever passed in to the container. So we'll see that in a second. And then the rest of it's the same. So it starts IIS, it invokes the web request. So by the time the application is running, these configuration files are actually pointing to somewhere else. The app doesn't know about it. The configuration files are actually coming from the cluster. So the way that works is, and Docker Swarm and Kubernetes, they all have the ability to store config files inside your cluster. So I've already done that. I've got here, let's clear some space. So if I do a Docker config list, config objects are first-class citizens. So I've already created a bunch of these things. If I go and inspect, let's say, my app settings, so let's clear it and make sure I've got that. So if I do a Docker config inspect, and if I put in the pretty flag, it will show me the contents of that configuration object, which is just this. So it's just a bunch of XML. This could be JSON, it could be plain text, whatever my application needs. Docker doesn't care. It stores it as an object, and then I can surface that inside the container. So in order to make this happen, I've got two changes for my next deployment. My first change is that I'm using version 2 of my app that's got that script which will redirect the config files. And the second thing I'm doing is I'm specifying where these files are coming from. So in my environment variables, I'm saying when the application loads up inside the container, you're going to look to this location for the application settings, and this location on the C drive for the log4net settings. And the cluster will populate those from the config objects that live inside the cluster. So when I start the application up, that content that I've just shown you from the cluster is going to surface inside the container as C:\\, and then the startup script will redirect it. So when the application is looking at inside the web root and it's looking for web.config or whatever, it's actually reading the content from there. OK, so I'm going to deploy this. And the way I deploy this stuff is exactly the same. All I'm doing is pointing it to a new version of my application manifest, my definition of all my applications. And at the moment, there's still only one component in my stack, in my applications, so it's just going to update that. So now, when I go back here, so I haven't refreshed. This is the existing application. The server name is the container ID, 11D, and then this is the default configuration that's packaged inside the app. There are 5 log entries and a few other bits that are coming from log4net. When I refresh this now, I will get a different server ID. That's the container ID. So that's my new container ID. That slow mode bit, I'll come to that later. That's exciting. The log count is now 2. That's coming from my configuration inside the cluster. So inside the cluster now, I'm managing this stuff, completely transparent to my application. And then the log4net config now, I'm setting it up to a different level, and that's stuff I'm managing inside the cluster too. So now when I click this button, and there's another button further down, so it's not just one button for the whole session. Now it says it wrote 2 log entries. And if I go and check out my container, don't delete your blog, don't delete your blog, don't delete your blog. Here are the containers. So there's 2 previous ones that have been exited because I've replaced them. Incidentally, that's how you do an update for your application or for a Windows update or whatever. You're never going to connect to a container and run Windows Update inside it. You're never going to connect to a container and upload a new file. You kill the container and you run a new one from a new image. So if I look at the logs here, so I'm not sure if this is a Firefox issue or a network issue or what, but sometimes it just goes blank, as you can see. So let's go back here. Services. I've got my web application. Look at the containers. And then in here, let's check the logs. So here are my logs. So I've got 2 of each. I've got debug level now because I've specified that in my configuration. And when it started, it's writing these entries to tell me that it's redirected the config locations. So whereas the application is expecting C web forms app log4net config, it's reading it really from here. So the config is coming from the cluster. OK, how are we doing? That was pattern number 2. I should time box these patterns. So the third one, so now I'm getting stuff out, I'm getting logs out of my application. I'm being able to feed config into my application. And all I've done is a little bit of smarts around the Docker file. There's a startup script that does most of this stuff in a few lines of PowerShell. It's just about thinking about how I can bring this application into the modern world and take advantage of the platform that it's running in without constraining me to running it in a certain way. So the next thing is dependencies. So all your applications are going to have dependencies, and the way that legacy apps are written, typically, there's this expectation of availability. So if I'm a web application that reads from a database, the code inside that application isn't going to have any exception handling or retries or anything to get to the database because the database has to be there. That's what this application does. The database is bound to be there because it's running on a server down there that's always been switched on. It's always got the same IP address, so I never need to worry about that. I never need to do retries or fault handling. In the modern world, those dependencies could be a database or a message queue or another component or anything. They are going to be transient. So the IP address will change all the time because it could be a cloud service. It could be another container. It could be a container that when I'm looking at it now, I've called into that container, I've made use of the functionality that I want, and then I go back and do what I want. And the next time I go back, it's a completely different container running on a different server with a different virtual IP address. But I might have cached the original IP address inside my application, and it's going to fail. So I need a way of being able to tell my application that for the application to check that the dependencies it has are available and check that before it starts. So the way this looks is, again, I'm going to package a utility inside my application container image. So I'm going to have my app, I've got my log relay utility, and I'm going to have a new utility that's going to check that everything is in place for the application to run effectively. It's going to run once before the application starts. So I can put whatever logic in there that I want. In this case, I am using a .NET application as my dependency checking utility because the logic I want to put in, it's better to be able to put that into the framework that the application is using. So it's another code base, but it's going to be able to make use of the .NET framework. And it needs to be, the advantage of doing that is that it can read the same config that my application is reading. So I could do it all with a PowerShell script, but inside the PowerShell script, I need to go to the config file and read it and parse it as XML, whereas actually it's a .NET application, .NET config, I might as well use .NET for my utility. So what this is going to do is when the container starts, this dependency checker will run, it'll do whatever it needs to do, and if the dependencies aren't there, it's going to stop, and the container will die. And then Docker will say, container's dead, start a new one. The new one will start. The dependency check will run. If the dependencies still aren't there because something's not ready or something's temporarily down, that container will die. And Docker will start a new one. And then it will run the dependency checks. And at this point, everything's available, so that container keeps on running. So it's just about a startup. Make sure everything's in place for your application to run because there's probably not any error handling inside the code. OK, demo. So for this one, I've got a new Docker file. This stuff's all on GitHub. I will show you the link at the end, so you have to stay till the end in order to see it. So here's my Docker file, version 3. Again, it's just additive. I'm just adding all the stuff that I care about. So all the first parts are the same. I'm copying in the zip file, I'm expanding it, da-da-da-da-da. I'm capturing where the paths are for my configuration files. And I've got a new flag in here, dependency check enabled. And this is about not breaking the developer workflow. So maybe inside this application, there are a bunch of dependencies, but when I'm a developer running on this stuff, I don't need them all to be able to work on the feature that I'm working on. So I don't want to run my container and it die because there's no message queue, because I'm not using that message queue. So again, this is don't break the developer workflow, allow them to opt out. When I run this in production, I'll say yes, but when I'm running it locally, it'll default to no. The rest of the stuff's all the same. I've got my script to do the startup, and then this is the bit here. I'm copying in, again, it's a zip file that contains my utility, and I'm just expanding it and making it available. Inside my startup script, which is here, and again, it's just PowerShell. This is the bit that redirects the configuration files. That hasn't changed. This bit here is the dependency check enabled, and if it is, then run the dependency checker utility. And if the dependency checker gives me anything but 0, which means there's a problem, then I'm going to return 1. And that tells Docker that my application's died. This container is no good. And then Docker will replace it. And then the rest of the stuff's all the same. So my dependency checker, just to show you vaguely what it does, without going into too much detail. Again, the source is all up there, so you can have a look if you wish to. So my dependency checker, which is a .NET console application. And all it does is it tries to make a connection to SQL Server. So my web application at the moment, there's another feature to be able to do something with the database. It doesn't check to see if the database is there, but my Docker file does do that check now by running this application. And because it's .NET, I can put all the nice stuff in about retries and all that sort of stuff. So this is what's going to run when I start my container. And to do my upgrade to version 3, I've got 2 things now. So I've got my web application. I'm using version 3 that's got the new features in it. I'm setting the dependency check on, so this will run the dependency checker when it starts. But I've also got SQL Server in here. So I'm going to run SQL Server in a container, and my application will connect to the SQL Server container. when it starts, Docker and Kubernetes, if I've got multiple components of my application running in different containers, they don't give you any guarantees about what starts first, because you can't really have that. If I've got a cluster with 100 servers in there, and I want to spin up a dozen database containers and 50 web application containers, I can't have the cluster saying, wait, I need to start this container for the database, and then that one, and then that one. And when all 50 are running, I can start this web. You can't have that. So Docker Swarm, Kubernetes, Mesos, they all just say, bang, here you are, go and create this stuff. And all your containers should have the logic to be able to deal with the fact that their dependencies might not be available. So when I deploy this, the database container will start up. Oh, actually, let's show you what it does first of all. So here's my existing application. This is the one that does the config. But so far, it's looking at localhost for the database. So this is what my default configuration for developers. When I click this button, execute SQL, it's making a call. It's trying to find a database at localhost, which there isn't, because this is running in a container. And eventually, it'll time out, and it'll give me an error. There you are. See? Error. Now, my new release will fix that problem. So I'm going to release my version. Which version is this? Version 3. Version 3. And this has got the new dependency checker stuff in it. Incidentally, I can deploy this through the UI. I'm just showing you that when you run a Docker command like this, it talks to a Docker API, which could be running local, or it could be a remote server or remote cluster. So that's how the CLI works. So it's creating. The application definition that I've got, the Docker compose file, is the desired state. When I do the deployment, it checks what's currently running, compares it to the desired state, and starts or updates whatever it needs to. It's created SQL Server, because that's new, and it's updated my web application container. So now, when I get here, let's go back to Docker. I've got a couple of services in my stack. I've got my new SQL Server. And this is just Microsoft SQL Server image. I'm not doing anything clever in here. If I go and look at the container, it's been up for a few seconds, so that's up and running. And if I go back and get rid of this filter and go back to my .NET application, hopefully, if I look at this, this is the new container. If I look at the logs, it will tell me. Yeah, here we are. So here's the new part. So validating dependencies. Did everyone get that? It said validating dependencies, and then it said dependency check OK. Now that means it's done that dependency check and it found SQL Server. Sometimes when I run this demo, it doesn't. And the output is it doesn't find SQL Server, it retries, it dies, and then Docker starts a new container. That's a better demo, but I can't make that happen because it's not deterministic. It depends on whether the SQL Server container is ready and available when the application container starts. So let's go back here. This is yet another new container. My database connection string. So now I'm also injecting new configuration for my SQL Server connection string. So it's not looking at localhost anymore. It's getting this from the cluster. I'm not going to go into details. This is not a config object. Actually, I will go into detail. The config object that I showed you, I did docker config inspect, and it showed me XML, yeah, for the number of log entries. This is using a Docker secret, and that's something different. It works in the same way, but it's encrypted. So I've got a connection string setting here. It's still just a lump of XML. But if I try and view that without using the word in, because that's not helping, if I look at the secret that's being surfaced there, I don't see any of the content. So it tells me the information about it, the metadata, but I can't see the unencrypted content. It's stored encrypted in the cluster. It's only delivered to a server if that server is about to run a container that needs that secret, and then it gets surfaced inside the container as plain text. So inside my container, I've got a connection strings file that's XML. But everywhere outside that, even as an administrator, I can't see the content of that secret. So yeah, I can't remember whether I was meant to say that or not. So here we are. When I click execute SQL now, I've got, all it does is gets the current time from the database. But that wouldn't work if it hadn't connected correctly. So firstly, I'm injecting my config setting for the connection string to find out where the database is. I'm using a secret for that, so it's all encrypted. And I've got my dependency check to make sure it's available before my application starts. As an end user, it would make no difference whether it was available or not. Because by the time I browse to the container, if the container is up and running, then it means the dependency check is passed and it's able to connect to SQL Server. Okay. When did you say? 12:55?
Yeah, just got about 8.
Oh, that's loads of time. That's loads of time. Okay, so number 4, health. Now, I've checked the dependencies before my application started. Okay, so that's my application won't start unless everything it needs is in place. The reverse of that is telling the container platform whether my application is actually healthy, whether it's doing what it should do. Now, when Docker starts a container, inside the Docker file, it tells Docker what to do to start your application process. If it's a console application, it's just going to run the console application. Any logs that come out from standard out will come into Docker. And if the console application dies, then Docker will stop the container because it's monitoring the process that starts when the container starts. Now, because of all the utilities and stuff that I've bundled here, the process that's actually starting inside the container is that PowerShell script. My application is sitting in the background here, running as a Windows service. Docker doesn't know anything about that. It doesn't know anything about Windows services at all. It doesn't know that W3WP is my actual process that's serving my requests. It's just looking at my PowerShell script. I want it to be able to tell Docker that my application is healthy, and that's more than just the process is alive. If it's a web application, my process might be running, but it might be maxed out and returning a 503 to every request. So I want to capture the logic in here to tell Docker that my application is actually healthy. So Docker has this feature that you can bundle a health check inside your Docker file and run some arbitrary stuff inside your container on a schedule. Docker will do that for you. So again, it's another utility that I'm going to bundle. Inside that utility, I will be exercising some of the main logic that I want to prove my app is healthy. So I can maybe call the website if it's a website, make sure I get a 200. I can check to see I get it within a certain amount of time. And then I can return back to Docker and tell it whether it's healthy or not. Docker will run it for me, but because I'm using a utility, Docker Swarm will honor the health check that's inside an image. Kubernetes has a different way of doing it, but because I'm packaging the utility inside my container image, I can tell Kubernetes to run that same utility. So I'm not limiting myself one way or the other. I don't know why I bother with the slides, because really it's just all demos. So version 4. Now then, here we go. Version 4 has the health check in it. So the rest of the stuff's all the same. So we're gradually productionizing this legacy application. The app's still the same. I'm putting the logic in to make it behave like a modern application. Right at the end here now, I've got this health checker. Again, it's a zip file from something that's already been built. I'm expanding that. And then I'm specifying the health check for Docker. So Docker knows every 2 seconds it will run that exe. And that exe will either return 0, meaning everything's healthy, or 1. And if it returns anything other than 0, Docker says this container is not healthy. Now, when I'm running locally, if my application's unhealthy, Docker doesn't do anything, because there's no redundancy if I'm running on a single server or if I'm running on a laptop. There's no point in Docker killing that application container, because that's even worse than it not being healthy. But when I'm in a cluster, if the application container is not healthy, then Docker will replace it, because it can do that in a safe way. My container's not healthy. I'm going to bring up a replacement here, send traffic to the new one, and kill the old one. So it can take care of that for me. You get this self-healing ability that you get with fancy new microservices, but applied to your legacy application. The other thing you can do is inside your application definition, you can configure how the health check runs. So this is my version 4. It's all the same up until here, but I'm saying the health check, it should run every 5 seconds. It should wait for 20 seconds before the very first health check, so to give the app time to spin up. So give it 20 seconds to spin up, and then every 5 seconds run that check, and then no retries. So the very first time it fails, then the container should be killed and the replacement start up. OK, and again, the deployment is exactly the same. So inside the health check, let me do my deployment first of all. So currently I've got A31. Now inside my health check utility, what I'm doing is again, it's just a .NET console application. So when Docker runs that health check, this will execute. And all it does is it tries to fetch from the local host. It verifies that the status response is OK, and that it comes back in under 150 milliseconds. So inside that web application, you know it said slow mode, and I said I'll come to that later. That's now. So every now and then, randomly, the web application takes too long to respond, which should trigger a health check failure. So when I go and browse to this now, this is a great demo because I never know whether it's going to work, because it only happens sometimes. So this is server 89A, so that's the container ID. This is version 4 that's got the health check, so Docker is firing these health checks every 5 seconds. Every now and then, it will hit a response that takes longer than 150 milliseconds, so it will fail the health check, and Docker will replace that container straight away, because it's not healthy. Now, if I keep on long enough, I will see that server name change. But I haven't got the time. So when I come back to this, by the time I've explained the last thing, it will have done it. It's not deterministic, you see. The application just occasionally goes bad, like real legacy applications. And when it does go bad, Docker will take care of it for me, but I don't have to do anything. I don't even need to be notified about it. We'll come to that in a second. OK, so that's the health checks. You can put whatever logic you need in there to execute the key parts of your application. The only thing to bear in mind is your health check is going to fire in, and it's going to use the resources inside the container. So you need to be aware of the fact that you don't want a health check that's going to use up 100% of your CPU. So you need to bear that in mind. You've got to get a balance, proving your app's healthy, but without destroying it. OK, the last one is metrics. So inside my Windows container, it's actually Windows Server 2016 running inside the container. It's got pretty much all of Windows Server, including the performance counters. So all the stuff that you get with Windows Server, IIS performance counters, .NET performance counters, that's all there. But it's hidden inside the container, just like my log file was. So what I want to do with metrics is I've got another utility that I'm going to bundle with my application, and that's going to provide an API which will surface those performance counter values. So what it's going to do is this little utility is just going to provide a REST API that another component could go and call into to retrieve the metrics about this application. It's going to run in the background, and it's just going to be there and providing the metrics that if they're used. The metrics that I'm exposing here are in Prometheus format, which is probably the most popular way of doing monitoring in containers. So Prometheus will collect all statistics from all these containers, and then you can build a really nice, friendly dashboard around all this stuff. But again, I'm not going to change code. I'm going to pack a utility with it that's going to give me that feature.
I'm curious about this new tool.
OK, this is the last demo. So demo number 5, Docker file number 5. And the only thing that's different here is right at the end, I've got a new component in here, which is my exporter. So I'm copying that from somewhere else. This is my utility, and it exposes a new port. So now when I release this deployment, I can connect to that port, and I will see the metrics that are running from my application. So before I do that, I'm just going to see if it's updated this one. No, it didn't. Oh, I hate that demo. OK, so now for this one, I'm going to deploy version 5, which has got my metrics in there. And let's do that. Inside my version 5 application definition, so this is describing the whole stack for version 5. I've got SQL Server, so I've got my database that's already running. I've got version 5 of my application that's got the metrics stuff in there, and I'm publishing my original web application port, but I'm also running Prometheus in a container. And this is a Linux container. So my cluster, remember, is some Linux servers, some Windows servers. I can run containers across different platforms, all connected to the same Docker network. And they find each other by the container name. So when Prometheus looks for my web application, it will find, even though it's on a different container, running a different stack. And I'm publishing port 9080 for Prometheus. OK, so let's see what we've got here. So that's a new container. So if I refresh this a few times, send in some load. And I'm also running Prometheus. So if I go and browse to my Linux load balance, so this is all running, the cluster's all running in Azure. There's some load balancers over the different servers. That's all that's happening here. So now when I browse, let's try that again. So now when I browse, no one's keen to get to lunch on time, are they? OK, so this is Prometheus. If you haven't seen Prometheus, don't worry. This is a really cool technology that you should probably look into. If you're looking at containerizing your applications, before you go live, you need to know what's happening inside your apps. And Prometheus is the best way to do the metrics. I've already got in here, because I've passed this configuration in to tell Prometheus what to do. And it's going to scrape my web application container every 5 seconds. So it's going to that web application container to the metrics API that I bundle with my utility, and it's going and connected to it. So I should be able to see that, oh, look at that, no such host. OK, so I'm going to spend the next hour debugging this issue. No, I'm not, obviously, because we're all going to go to lunch. So I'm not going to show you this, which is a shame. That's such a shame. I'm not sure why I didn't find it, actually. Let's go and look at my services. I will time box this debugging session to 1 minute. So let's have a look. I've got SQL Server, I've got web, I've got Prometheus. There's an error here. I know what this is. So this exited. I guess that's because the dependency failed. What's this one doing? Page loaded, yeah, that's fine. I expect this is just a timing issue. Ah, see, the health check triggered and it failed, and that's why Prometheus couldn't find it. That's why I hate this second demo. So let's try this again. Prometheus should find it now. Yeah, it's up, excellent. So I can go to the graphs. And all this stuff here is Windows performance counters. I'm doing nothing to make this happen. The utility that I've bundled in here is a really simple .NET utility that just reads them and makes them available. So if I go and look at requests per second here and look at the graph, this is requests per second coming from IIS. And the interesting thing here is, let's zoom in back to here. You see there are two lines here. That's because there were two different containers. So in the time that Prometheus was scraping these metrics, the container got killed and replaced. I could aggregate these, but this is showing me the different ones. So this is the first one that I hit a few times, and this is the second one. So that's metrics coming from my .NET application without me having to do anything special. OK, so I've done that. Now, this is my cluster, my hybrid cluster. So I've shown you stuff running on Swarm, but you can also run Kubernetes on the same cluster. So you've got different teams with different preferences. You can deploy everything on one set of infrastructure. So I can have my .NET monolith on Swarm, my Java monolith on Kube. I can run my cloud native app on Swarm and my serverless framework on Kubernetes, all on the same set of machines in my data center or in any cloud. Take a photo of this. So this is, if you want to try out the cluster technology I've been using, there's a trial.docker.com that will spin you up an environment. This is a bunch of YouTube videos about modernizing apps, either from a dev perspective or an IT pro perspective. This is where you find the demos for today. This is where you should come in December to Barcelona for our conference, and that's a thing that gives you 20% off. Sorry I went over. My name's Elton. Any questions, just ping me, and I'll be glad to answer, and I'm around for the rest of the day. So hope that was useful. Sorry I went over.